Hey, how's it going everyone? Welcome back to my Godot behavior tree and navigation series, part 5. In this video, we will be adding a line of sight check for our enemy so that when the enemy has line of sight to the player, it will try to follow the player. And if the player manages to break line of sight, then the zombie will stop following the player. Okay, let's jump in. Okay, so the first thing we need to do here is let's go into our enemy script and let's add a new task down here. Let's call it function task has LOS, line of sight, and pass in the task argument. And just for now, let's call task dot succeed because right now we're going to be adding some parts that are needed for us to actually do line of sight check. So let's leave it at that right now. How our line of sight check is going to work is like this. We have a enemy and a player right here, and we're just going to be doing a simple raycast from the enemy to our player. And if this cast doesn't hit anything, so it successfully hit the player, then we know there's nothing between the enemy and the player. So the enemy has line of sight to the player, but if we have like a box in between them, then the raycast should hit this box instead of hitting the player because this box is right here. So in this case, we know that the raycast hits something else other than the player, so that in this case, the enemy doesn't have line of sight to the player. So this is what we're gonna do. If you have used Godot before, and especially some game like a side scroller or a platformer, then you probably would know that there's a node called Raycast 2D or Raycast node, and what it does is query the closest object intersecting array, and if you add it in here, it looks something like this. So you might want to use this to do our line of sight check because it's also raycast. But the issue with this is that the raycast node, if you look over here, there's a cast to position, and this position is actually relative position. So if the enemy is facing this way and your cast to position is 0, 50, it's gonna be down here. But if the enemy is facing another way, let's say like this, if it's 80 degrees rotation, then even though your raycast cast to position is the same, it's going to be casting to a different direction. So in our case, this will be a little bit more tricky to handle, so we're not actually going to be using the raycast node. So let's just delete this and let's go back to our enemy script. We would also want to visualize our raycast on screen, so let's go back to our main scene here and let's add in another line 2D node. So let's just add a new line 2D node and let's just call this raycast line 2D. Let's give it a capital R, raycast line 2D, and okay. Now let's go back to our enemy script, and just like our line 2D, let's just copy this line. You can use Control D and change this to raycast line 2D, and also change the name right here to raycast line 2D, so it will be able to find the correct node in our scene tree. Okay, now let's go back to our enemy script and go back to our task has line of sight check, and let's add in the script here. So first, let's define a variable called succeed. So this means whether we succeeded, whether the line of sight check succeeded or not. And so this is what we're gonna do with the raycast. We're gonna first be getting the space state of our game. So it's get world 2D, and get the direct space state. With this space state variable, we can call a function called intersect ray. So we're going to be calling space state dot intersect ray, and this is the raycast function. It takes in a from position and a to position and an array that we want to exclude from the raycast and some other stuff. So let's put in our enemy position first. So get global position, and let's put in our player position. So we want to raycast from the enemy to the player. So player get global position. And for the exclude array, let's pass in self for now. And let's store the intersect, the raycast result into our result variable. Now let's take a look at Godot's documentation on the space state intersect ray function. So if you go to the documentation website and if you look at physics 2D direct space state, and there's the intersect ray function right here, and after clicking on it, it'll bring you to the documentation of that function. So you can see that the return value is a dictionary, and also all the parameters that you can pass in and what they do. So the dictionary that it returns actually looks like this. So there's a Raycasting Godot documentation on how to do raycast, which is really awesome. So the result dictionary over here is going to contain these information. So the key position is going to be the collision position in world space, and also the normal of that collision, and also the collider. So it's going to be an object that got collided with. So let's go back to our script. So we know that if the returned result is empty, so it has nothing in it, then it means we didn't hit anything. In our case, if we didn't hit anything, that means we have our line of sight, has line of sight to player. So the succeed variable, let's set it to true right here. And if the result dictionary is not empty, which means we hit something, then it means that we hit an obstacle between us and the player. To draw that on our screen with our newly added Raycast line 2D, let's make a new variable here called points. And right now it's just going to be an array, and let's just put in global position. So our enemy's global position here, that will be our first point. And if we didn't hit anything, let's points dot append. Let's append another point so that this will be our player position. Player dot get global position. And if the enemy doesn't have line of sight, so if the raycast hits something, we are going to append another point, which is from the result we get the position, so the position that the raycast hit, and let's append that. And also there's a typo here, and let's assign that the points array to our raycast line 2D. So raycast line 2D dot points equal to our points variable. And finally, if our succeed variable is true, then we call succeed. If not, then we call task dot failed, so that this behavior tree node will succeed or fail according to whether we have line of sight to the player or not. Now let's go into our behavior tree editor and add that line of sight check to our enemy. And let's just go into our enemy scene and click on the B tree here. So we're going to be adding a new task here. So let's add a new one and reconnect these and add a new task. connect this and use the has line of sight check. So how this is going to work is that the behavior tree will start evaluate from the root node, and then when it encounters this sequence, it will first check if the line of sight is successful, and then it will keep moving on if it is. Otherwise, it will just fail, and this sequence will fail, and then the behavior tree will start trying again from the root. So let's just give that a test. And we got an error. So we forgot the right here. And okay, let's just give that another try. As you can see, the enemy is not moving, but our line of sight is drawing correctly. So when there's no obstacles between the enemy and the player, the line of sight is reaching the player. But if there's a obstacle like a box here, then the raycast will hit the box and won't reach the player, so we know that it doesn't have line of sight. But right now it looks like it's always failing because it's not moving at all. So let's go into our script and let's put a breakpoint here to take a look at what's going on. So you can just click over here, and because it's constantly calling this function to re-evaluate that node, so it will hit the breakpoint, and we can see that right now the dictionary has a size of 7, so the result is not empty, which means that it is hitting something. And let's take a look at the dictionary in here, and we can see the collider ID, the collider. And if we click on the object ID right here, and it's gonna bring us to this, and we can see that this is actually, if we click on remote here, and this will show the current scene that it's running, and this is actually our player kinematic body 2D that it's hitting. So if we bring up that our game, you can see that it's not actually reaching the player. Well, it is, but it is hitting the player's collision. So the sphere collision right here, it is hitting that collision. So that's why the result here is not empty. So you can see that this doesn't match with our comment here, because we want to determine when it has line of sight, it shouldn't hit anything, but right now it's hitting the player. So this is just because we didn't pass in any collision mask to the raycast, so it's hitting everything in the scene. That's why it is also hitting the player, but we actually don't want to do that. We just want the raycast to be able to hit other stuff like static collisions and other collisions in the scene and not the player. Let's stop the game right here and let's go back to our script. Actually, we're going to be going into our project setting. So let's click on project settings here, and let's go down to our layer names, 2D physics layer. So right now it's just layer 1, 2, 3, 4, and you can have 20 different layers at most for now, but we can give these layers names also. So let's just give the first layer, let's call it static. So this will represent static collision in our game. And the second layer, let's call it player. This will be the player collision. And the third layer will be enemy. And after that's done, let's just close it. So what is it exactly that we need to pass in here? We know we want to pass in a raycast, let's call it raycast mask, and this is going to be of type integer, and we know we want to pass this in our raycast function, but we don't know what the value of this should be. But we can go to our, let's say, enemy, and take a look at our enemy's collision here, And now after we name all the layers, you can actually see that the names showing up right here. So the first layer will be static, and you can see that the bit is the 0 bit and the value is 1. And the second layer is the player layer, and the bit is 1 and the value is 2. And the third layer is the enemy layer, and the bit is 2 and the value is 4. And if you're confused about this is just because it's using a integer to store the whole layer mask. So the first bit, the value will be 1 because it's 2 to the power of 0. And the second will be 2 to the power of 1. So by doing this, we can just store the layer that we want to collide with, or the layer that an object collision is on with a single integer. And when we want to check against a layer in a mask, we can just use a bitwise operation like a bitwise and if the result of that is not 0, then we know there are some layers match up with the mask. Before we can go in and test again, we need to change one more thing. So let's go to our player and let's go to its physics body 2D collision. And you can see that we haven't updated our layer in our mask setting here. So for our player, we'll want the layer to be our player, of course. So we don't want the static to be flagged. So it's just going to be bit number 1 and the value will be 2. And for the mask, we want the player to be able to collide with static and enemy. And we probably don't want it to collide with itself, even though we only have one player here, so that really doesn't matter. But let's pick static and enemy. So this is going to be our layer and mask setup for our player. Now let's press start and give that another try. As you can see, our enemy is moving now. And you can see that the raycast is casting to the player. If it's not hitting anything, then it will move to the next node after it is succeeded the line of sight check node. And if the player is hiding behind a crate, then the raycast will hit the crate and it will determine that it doesn't have line of sight to the player, so it won't move. And because right now both of our line of sight line 2D and our path line 2D are using the same color and the same width, same settings, so they are indistinguishable from each other. So we can go ahead and change that real quick. We can keep the line 2D for our path the same, that's fine. Actually, let's make the width a little bit lower, probably 5. And for our raycast line 2D, let's make it thinner. So let's change it to something like 2 and give it a color, maybe red, so it's easier to see. Let's give that another try. Well, we also have the navigation mesh debug enabled all the time, so that's why it's kind of blurry here. We can also close, disable that. Let's just disable visible navigation, and we also don't really need visible collision shapes, so let's just uncheck those. And now you should be able to see the line of sight check and the path more clearly, like this. Before we end this video, let's just go ahead and do one final change. So let's go to our enemy, and as you can see, we haven't updated its layer and mask, so let's just go ahead and do that. For layer, we're gonna use enemy layer and uncheck the static layer. And for mask, we want it to collide with static and player, so let's just also check the player right here and save your project. So that's it for this video. We added a new line of sight check for our enemy, and we also added a sequence in here so that it's going to do the line of sight check first before it tries to find path and move to the player. In the next video, we are going to add a wonder behavior for our enemy. So when it doesn't have line of sight, it will just go into wonder instead of just standing there. So if you enjoyed this video, please leave a like, comment, and subscribe. I really appreciate it. Thanks for watching, and I'll see you guys in the next one. Bye.